This is where we were when I ran out of time in the last video, talking about the maximum number of turnaround points. Two little facts here. The maximum number of turnaround points is 1 less than the degree of the polynomial, and the degree of the polynomial will also tell you the maximum number of zeros there are. And what the maximum number of zeros there are refers to is how many times it crosses the axis. So I've drawn out a couple of possibilities. This does not cover all of the possibilities. This is just a couple examples so that you can understand this definition. Degree 3 can cross the axis at most 3 times. So I've given you 3 zeros. This is telling me that the maximum number of turnaround points is 1 less than that. So this thing can turn around twice at most. The most logical thing on this is to come up, come back down, come up, and there's our 2 turnaround points. That does not have to be what the picture looks like. Depending on the end behavior, it might go the other direction. It might have gone this way, come through here, and back down. That's what it's going to look like pretty much if it's going to have degree 3 and it will have 3 zeros. Possibility of degree 3 that it only crosses the axis once. When we get into another lesson, I'll explain about why it crosses the number of times it crosses. All we're talking about here is the maximum number of times it can cross as it relates to the maximum number of turnarounds. So it is possible a degree 3 just crosses 1 time. Well, it still has a possibility of 2 turnarounds. And it could have 2 turnarounds because it might come through here and it might still dip. So here's 1, 2 turnarounds. Potentially degree 4 can cross 4 times at most, and then maybe it's going to go something like this, up, down, kind of like a W. I could go the exact opposite direction like an M, but count your number of turnarounds. 1, 2, 3 turnarounds, which is 1 less than 4. It's possible that degree 4 only crosses twice. And then our turnarounds might just be something like this. It might just go through kind of like a parabola, and it only has 1 turnaround. Remember, this says that the maximum number of turnarounds is 1 less than degree. So the most it can have is 3. It doesn't have to have 3. Again, this does not cover all of the possibilities for what the pictures look like. I'm just trying to get you to understand the idea about the maximum number of turnarounds. This is a listing of all of the things you need to do to graph a polynomial function. The only thing I do is change this order. This is the order that's written in your book, but I always find the intercepts first. It just helps me know how many zeros I'm going to have. So I find the x-intercepts by setting the polynomial equal to 0, and you do that by factoring and solving. If there is a multiplicity greater than 1, you've got these 2 possibilities. If k is even, the graph is going to touch the x-axis at the intercept and then turn around. I call that a bounce. If k is odd, the graph will cross at that intercept, but you often get this little wiggle thing, which I will show you when we get to one of those examples. Then I use the leading coefficient test to figure out what's going to happen at the ends. These 2 are very easy to do and very important. They give you a very good picture of what's going on with the graph. This helps us get a little more specific. Find the y-intercept by computing f of 0. Use symmetry if possible. If it's an even function, there is y-axis symmetry. If it's an odd function, there is symmetry to the origin. This doesn't happen a whole lot. It doesn't help that much. Here's this maximum number of turn points idea I just went over on the other screen. And then the last thing you have to do is complete your picture by plotting points that are between and beyond the zeros. First step is to find your zeros, so set that equation equal to 0. Factor and solve. The factoring is take out the GCF, set each one of those things equal to 0, and we end up with these zeros, x equals 0 and x equals 3. But because this is squared, this root of 0 has multiplicity 2. And what does multiplicity being even mean? It means that it's going to bounce right there. That will help us get a pretty good idea of what this picture looks like. Next thing to check is symmetry. This is neither even nor odd. There is no symmetry, so that didn't help any. And behavior, because that's odd and that's a positive coefficient, I know it falls left and rises to the right. Y-intercept, plug 0 in up here, so it gives me the ordered pair 0, 0. That didn't help any because I already have that ordered pair as one of my roots. Maximum turnarounds, because this is x cubed, the maximum number of turnarounds is 2. Doesn't mean it has to turn around 2, that's just the max. Based on the end behavior, put together with the bounce idea, I know that this is going to come up this way. It has to bounce at 0. So the only way it's going to bounce, since it's coming up here, is it's got to come back down. And it's got to get back to this point right here, so it's got to eventually turn around and come back up. There's my two turnarounds, here and here. What I don't know yet is this: how far down does it go? And that's what the T-chart's all about. Let's pick 1 and 2 because those are the numbers between my two zeros. If you put 1 in here, you're looking at -2. If you put 2 in here, you're looking at -4. Now, where did I get those? I've already done the arithmetic on this to save some time. If you need to stop the video, plug the numbers in, do the arithmetic, and you'll verify that these are the correct answers. So let's erase this little part and go back to my real graphing. Over 1 down 2, over 2 down 4, and I know it's going to go like this. As I discussed in another video, is this absolutely the lowest point? I'm not sure. Until you get to calculus, we really can't tell. I'm just going to assume it just stopped there and came back up. It might have gone a teeny bit further before it went up. We'll look at it on a graphing utility in a second and see how close we are. So there is our graph. Those were our zeros. Our end behavior was fall left, rise right. We got the rest of this curve in here because of our T-chart. This bounced here because this 0 root had a multiplicity of 2, which is an even number. The graphing utility of it, and it looks pretty much like the one I've got graphed on the other screen. 3x to the 4th minus 6x cubed. Set it equal to 0. Factor out a GCF of 3x cubed. Set each one of those equal to 0. And solve, and we get zeros of 0 and 2. But that's an odd power, which means this 0 has multiplicity 3. That's an odd number. What does that mean? That means it's going to cross at that root. It's not going to bounce like the last one. It's going to cross. So 0 and 2. Does this have any symmetry? No. This is neither odd nor even, so there is no symmetry. And behavior, this is an even power with a positive coefficient, so I know it rises, rises. Probably not that wide. I just have a hard time with this pen. Y-intercept, plug 0 in for both of those, gives me the point 0, 0, which doesn't help any because I already have that point right there. Maximum number of turnarounds, because this is x to the 4th, the maximum number of turnarounds is 3. The maximum, it doesn't mean it has to do that. Let's take a look at what's going to happen with the T-chart. The number between 0 and 2 I would use is 1. So when you plug 1 in here, you get -3. So 1, 2, 3, and just smooth this out. Now this is what I meant earlier when I said if it's got this odd multiplicity, there's a teeny little wiggle here. It doesn't come straight down. It kind of goes over and then comes and goes up. And you'll see the wiggle better on the next screen where it's already graphed for you. See the wiggle right there? The reason it's wiggling is because 0 was a root of multiplicity 3, which was an odd number. F of x equals -x cubed minus 3x squared plus 4x. Set this equal to 0. Factor out a GCF of -x, which gives us this trinomial, which factors further into this. Set each one equal to 0 and solve. We get those 3 zeros. There is no fancy multiplicity here. Each of these factors occurred only once. So I'm going to have a 0 at 0, at 1, and over here at -4. Is there symmetry? No, it's neither even nor odd, so no good there. And behavior, since this is x cubed, which is odd, and the coefficient here is negative, I know it is going to rise to the left and fall to the right. Y-intercept, put 0 in here, we're going to get 0, 0. So here we go again with a y-intercept that didn't help because that 0 happened to be one of my zeros. Maximum turnarounds, because this is x cubed, the maximum number of turnarounds is 2. Now just knowing that information and seeing this, if this is coming this way, and I'm going to have to go through this right here, I know this is going to come down, turn around, that's one turnaround point, come back up, and go. What I don't know is how far down, how far up, and that's what the T-chart's all about. So over on this side, I would like to use -1, -2, and negative 3. On this side, I need to pick a number between 0 and 1, which is a half. Yes, I know arithmetic with fractions can be ugly, but you can use your calculator and get that right. So I've already done this arithmetic, so I'm just going to fill in. Negative 1 is negative 6. Negative 2 is negative 12. Negative 3 is negative 3. And 1/2, I'm just going to write it as a decimal, 1.125. You can verify these, stop the video, plug these in, and see what you get for the numbers. All right, let's plot these. Negative 1, negative 6 is right here. Negative 2, negative 12 is somewhere down here off the graph. Negative 3 is here. And then 1/2, 1.1 is just a smidge higher than 1. So if you follow your dots, you can see this.